Assalamualaikum, my dear students. How are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIEVS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Day Shift. Today, I am going to take a physics class for class 9 students. My dear students, our today's topic, Chapter 5, Discussion Part 3. Today's lecture number 13 and SW number 10. My dear students, now start our class. This is Chapter 5, State of Matter and Pressure. Today, first of all, we will discuss Archimedes Law. Okay, today we will discuss about Archimedes Law and Pascal's Law. Okay, now everyone see this figure here, given a picture. The law is, Archimedes Law will be, the law is if a body is immersed in liquid, if a body is immersed in a liquid, the weight of the body is reduced by an amount equal to the displaced liquid. Okay, my dear students, this is the laws of Archimedes. Okay, this is the laws of Archimedes and you have to memorize properly. If a body, the law is, if a body is immersed in a liquid, the weight of the body is reduced by an amount equal to the displaced liquid. Now, we will find this law. A cylinder is immersed in some amount of liquid is shown in this figure. In this figure here, given a cylinder and it is immersed in some liquid. Okay, and this can be any object of any shape, but for the convenience of calculation we took a cylinder. And let us suppose that the height of the cylinder is h. My dear students, see here, given the cylinder is h. Okay, the height of the cylinder is h here, and the cross sectional area of the bottom and top of the cylinder, the cross sectional area and the bottom and the top of the cylinder is a. So, area is a, and we imagine that cylinder is immersed in such a way, the depth of upper surface, the depth of upper surface is h1 and lower surface is h2. Okay, we have said many times that pressure in a liquid or gaseous does not work in a definite direction. Okay, the pressure in liquid does not work in a definite direction, it works in all directions, and therefore the downward pressure acting on the upper surface of the cylinder, the downward pressure acting on the upper surface of the cylinder, and it will be P1 equals to H1 rho g. From this formula, P equals to H rho g, we can write P1 equals to H1 rho g. This is the downward pressure. This pressure is the downward pressure, and this downward pressure acting on the upper surface of the cylinder. Okay, it will be acting on the upper surface of the cylinder, and so this pressure will be P1 equals to H1 rho g, and the upward pressure acting on the lower surface, upward pressure acting on the lower surface. Okay, so it will be P2 equals to H2 rho g. This pressure, this upward pressure acting on the downward. Okay, and therefore the downward force acting on upper surface and upward force acting on the lower surface respectively. So we can write from P equals to F by A, this formula we can write F1. That means F equals to PA. Okay, so by using this formula we can write F1 equals to AP1. Okay, AP1. Now put the value, F1 equals to A into P1 means H1 rho g. Okay, and F2 will be equals to A H2 rho g. Okay, so we do not think about how much force is exerted on the surrounding surface, because the force experienced by the cylinder from one direction is equal and opposite to the force from another direction and neutralize one another. Okay, then as the volume of H2 is greater than H1, so we see that the value of F1 is greater than F1. So F2 will be greater than F1. So we can write F equals to F2 minus F1. Now put the value F2 means AH2 rho G minus F1 means AH1 rho G. Okay. So from this we can write that A into H2 minus H1 rho G. Okay. Then F equals to A H rho G. Okay. So my dear students, here AH is the volume. Okay. H is the volume of this cylinder and rho is the density of this cylinder and G is the gravitational acceleration. So therefore the force exerted upward is equal to the weight of the liquid. The force exerted of the upward is equal to exerted upward equal to the weight of the liquid which has some volume as the cylinder, and this is known as the Archimedes law, and the upward force is called buoyancy. Okay, this upward force is called buoyancy. Okay, my dear students, I hope all of you have understood Archimedes law. Practice properly at home this law. Now come to flotation and immersion of body. You have surely understood why an object floats and why an object is immersed. You know an object experiences an upward force due to buoyancy, and which is equal to the weight of the water displaced by the object when it is immersed in water, and the object will float if the force is greater than the weight of the object. My dear students, you have to underline this line. This is important line. Okay. An object experiences an upward force due to buoyancy which is equal to the weight of the water displaced by the object when it is immersed in water. The object will be float if the force is greater than the weight of the object. Just the portion of the object which is immersed so that it will displace water equal to the weight of the body, only the portion will be immersed. Exactly the remaining part will not be immersed in water. And if the weight of the body is greater than the weight of the displaced water, the body will sink in water. So, but it seems that the weight of the body when immersed is less than its real weight. And if the weight of the displaced water can be made just equal to the weight of the object anyway, and then the object remains there where it is put in water and it will not float above or even sink below. And in our everyday life, though it is not seen by us, but for the movement of the submarine underwater, this is done. My dear students, this one is important for short question answer, and memorize properly why an object is float and why an object will sink. Okay, now comes to next lesson, Pascal's law. Pascal's law, the law will be if pressure is applied on a liquid or a gas enclosed in a container from outside, then this pressure is transmitted equally and acts perpendicularly on the surface of the container in contact with the liquid or gas. My dear students, this is the states of Pascal's law. Okay, now applications of Pascal's law. Using Pascal's law, some interesting machines can be fabricated. In figure, this is a machine like that is shown, and here are two cylinders. Are connected by a pipe. Here this is first cylinder and this one is second cylinder, and these two cylinders are connected by a pipe. Okay, and let's suppose cross sectional area of cylinder A is A1 and that of another cylinder is A2. Suppose this cylinder, the cross sectional area of this cylinder is A1 and cross sectional area of this cylinder is A2. Okay, the cross sectional area of this first cylinder is A1 and second cylinder is A2. Okay, then you have applied force F1 on the cylinder of cross sectional area A1, and then you apply your pressure will be P equals to pressure will be P equals to F divided by A. By using this formula, we can write that if we apply F1 force F1 on this cylinder, then we can write P equals to F1 divided by A1. And now this pressure is transmitted through the liquid in all the directions, and it will also be applied on the cross sectional area of the second cylinder. My dear students, I am repeating this one. Now this pressure, that means this pressure P will transmitted through all the liquid in all directions, and it will also be applied on the cross sectional area of the second cylinder also. And therefore the amount of force applied on the second cylinder, it will be F2 equals to P A2. Okay, from second cylinder F2 equals to P A2. Then put the value P means, here P means F1 divided by A1 into A2. So we can write F2 equals to F1 into A2 divided by A1. Okay. So this is the force for this second cylinder. This force will be the for second cylinder. Now therefore you see amazingly that if the magnitude of A2 divided by A1 is 100, then we will get 100 times more force on the second cylinder than the force you applied on the first cylinder. Okay, and this process is very effective, and it is used to control very large factories and aircrafts. Okay, by using this process can control this very large factories and aircrafts. But keep in mind, it is the principle of increasing force. Okay, it is the principle of increasing force, and in this process energy cannot be increased at all. You will get back the same amount of energy on the second cylinder that you have applied on the first cylinder. My dear students, we can get the same amount of energy from second cylinder that we can get that we applied for the first cylinder. Okay, my dear students, our your today's SW number is 10, and your laws of Archimedes and Pascal. That means this laws of Archimedes and laws of Pascal, do this one as your SW and submit it on Saturday. My dear students, I hope all of you have understood our today's topic. Practice properly at home, and memorize properly the laws of Archimedes and Pascal. See you again in the next class. Allah Hafiz.